Hello, my brilliant students. A big welcome to all of you getting ready to absolutely conquer your WAEC, NECO, and JAMB exams. I'm so excited you're here with me today because we're going to break down a topic that is, well, it's a heavyweight on your chemistry paper: crude oil and petrochemicals. Okay, let's be real. I know this topic can look a bit scary, right? All these big words like fractional distillation and catalytic cracking, it can feel like a lot. But listen, I want you to just take a deep breath and relax. Because in this explainer, we're going to make this topic so simple, so clear, that you'll be looking for these questions in the exam hall. It's going to be a guaranteed high-scoring area for you. Trust me, you've got this. So what's on the menu today? Well, everything we're covering is pulled straight from your official exam syllabus. That means zero time wasted, every single minute counts. We're going to start with the basics. What even is crude oil? Then, how do we separate it into all the useful things we need? We'll look at the main products, petrol, kerosene. Then we'll get a bit clever and see how chemists improve those products. And finally, we'll bring it all home and talk about why this is so important for us here in Nigeria. Ready? Let's get into it. All right then. First things first, let's lay the foundation. Before we even think about petrol or kerosene, we got to ask the most fundamental question. What exactly is crude oil? Okay, here's the number one thing you have to remember. Crude oil, or petroleum as it's also called, isn't just one substance. No way. It's this thick black liquid that's actually a mixture. It's a super complex mix of thousands of different compounds called hydrocarbons. Just think of it like a really complicated soup. You wouldn't just drink the whole pot, would you? Nah, you've got to separate the ingredients. And that's exactly what we have to do with crude oil to get all the useful stuff we need every single day. So that's the big question, isn't it? How on earth do we separate this complex soup? Well, this brings us to the superstar of this topic, the one industrial process you absolutely positively have to know. I'm telling you, WAEC and NECO, they love asking questions about this. It's called fractional distillation. So I need you to lean in and pay close attention here. This is important. The idea behind it is actually pretty simple. It's all about boiling points. That's the secret. So picture this. We take the crude oil and heat it up in a furnace, like really hot to about 400 degrees Celsius, until the whole thing turns into a hot gas or vapor. Then we pump this super hot vapor into the bottom of a giant tall tower. That's our fractionating column. Now here's the magic trick. It is boiling hot at the bottom of this tower, but as you go up, it gets cooler and cooler. So as all those different vapors start to rise, they cool down. The ones with really high boiling points, the heavy guys, they can't handle the cold, so they turn back into liquid or condense and get collected on trays near the hot bottom. But the lighter guys, the ones with low boiling points, they just keep on rising, climbing higher and higher to the cooler parts at the top before they finally condense. Simple, right? And boom, this table shows you exactly what we get. These are the main fractions collected at different levels. Right at the cool top, we get refinery gas. That's your cooking gas at home. Come down a bit, and there it is, petrol for our cars. A little lower, we get naphtha, which is super important for making plastics. Go down again, and you find kerosene for jet fuel and, our gen lamps. Then comes diesel for all the big buses, trucks, and generators. We're getting near the bottom now, so we get the thick stuff, lubricating oils for engines. And right at the very bottom, that thick, gooey residue that couldn't even vaporize, that's bitumen, the tar we use for our roads. Now, do you see the pattern here? It's key. The longer the carbon chain in the molecule, the higher its boiling point, and the lower down the column it gets collected. It's a perfect system. Okay, I know what you're thinking. How am I supposed to remember all that in the exam hall? Don't worry, I've got you covered. Here's a little memory trick, a mnemonic, to help you remember the order from top to bottom. Just remember this sentence. Remember, people need kerosene during long blackouts. It makes sense, right? Let's break it down. R for refinery gas, P for petrol, N for naphtha, K for kerosene, D for diesel, L for lubricating oil, and B for bitumen. Seriously, write this down. It's going to be your secret weapon in the exam. Okay, let's keep building on this. Now we have a problem. Here in Nigeria and really all over the world, everybody wants petrol, right? The demand is massive, but the amount of petrol we get directly from distillation is just not enough. We end up with a lot of these other fractions with really long, heavy molecules that aren't as useful. So what do? Well, some brilliant chemists came up with a genius solution, a process called cracking. And cracking does exactly what the name says. It literally cracks those big, long hydrocarbon molecules, breaking them down into smaller, more valuable ones, like petrol. Now, there are two main types you absolutely have to know for your exams. First, you have thermal cracking. Think, thermal means heat. This one uses crazy high temperatures and pressure to break the molecules. It's great for making alkenes, which are the building blocks for plastics. Then you have catalytic cracking. This one is a bit smarter. It uses a lower temperature, but adds a secret ingredient, a catalyst, to make the reaction happen. And its main product, high quality, high octane petrol, the good stuff that stops your engine from knocking. Let me show you what this looks like with a simple equation. Let's take a molecule of decene, that's C10H22. You'd find that in the kerosene fraction. It's okay, but not what we really want. So we crack it, and it can break down into, say, a molecule of octane, that's C8H18, which is petrol, yay, and a molecule of ethene, C2H4, which is used to make plastics. How amazing is that? We took one less valuable molecule and turned it into two super valuable products. Now, quick side note, but it's important. Besides cracking, which breaks molecules, there's also another process called reforming. Reforming doesn't break things, it just rearranges them. It takes straight chain molecules and twists them into branched ones. Why? This massively improves the quality of petrol by increasing its octane number. All right, you have soaked up all the key concepts. You've done the hard work, so now it's time for the fun part. Let's apply this knowledge and see exactly how those examiners are going to test you. Come on, you are so ready for this. Okay, first up, a classic question from WAEC. This one is from 2018. See how it connects petrochemicals, that's the chemical industry part, all the way back to crude oil. Let's break it down piece by piece. Essentially, the question is asking, hey, where do we get this stuff to make plastics from? All right, let's solve this. Part I, the raw material fraction for plastics. That's our good friend, the naphtha fraction, simple. Part 2, how did we get that naphtha in the first place? Come on, you know this. From fractional distillation, of course. And finally, part 3, name 2 of the gaseous hydrocarbons used to make the polymers. Well, we get them by cracking the naphtha, and the 2 most famous ones are ethene and propene. See, it's like a story. Distillation gives us naphtha, and then cracking naphtha gives us the building blocks for plastics. It all fits together. And this right here, this brings me to a super common mistake I see students make all the time. Please, please, please listen up. Do not mix up fractional distillation and cracking. They are not the same thing. Think of it like this. Distillation separates. It's a physical process to sort out the mixture. Cracking breaks. It's a chemical process to change the molecules. Just bend this into your brain. Separate versus break. Got it? Next up, let's look at a JAMB question from 2006. Now, this one is very specific to us, to our own Nigerian crude oil, which you've probably heard of as Bonny Light. The question asks why it's called light. Oh, JAMB loves these kinds of questions, the ones that test that specific bit of knowledge you're supposed to know. Okay, let's dissect this because this is a classic JAMB trick. You have to know 2 key terms, light and sweet. Light crude oil technically means it has a low density. Sweet crude oil means it has a low sulfur content. Now, the cool thing is our Nigerian Bonny Light crude oil is famous for being both light and sweet, which is why it's so valuable. But here's the exam tip. When they ask about the quality or what makes it desirable, the most important factor they are almost always looking for is its low sulfur content, the sweet part. It makes it cleaner and easier to refine. So looking at the options, the best answer, the one that defines its high quality, is A, low sulfur content. And for our last one, let's take a look at a nice straightforward question from NECO 2009. This one is a direct test of your memory. No tricks, no long stories. They just want you to spot the odd one out. This is what we call easy marks. And this is where our secret weapon, that mnemonic, comes in to save the day. Remember, people need kerosene during long blackouts. Let's just scan the options. Bitumen, yep, that's B for blackouts. Diesel, yep, D for during. Kerosene, of course. Petrol, yes, P for people. What about coal? Is there a C in our sentence? No, because coal is a totally different thing. It's also a fossil fuel, but it comes from plants, not the marine stuff that makes oil. So coal is the outsider. The correct answer is B. See? Easy marks. Fantastic work, you guys. That was brilliant. We've gone through the theory. We smashed some real past questions. Now let's just pull everything together and do a quick fire summary of the most critical points you need locked in your brain for exam day. Okay, here it is. Your final revision cheat sheet. Just 3 key processes to remember. 1. Fractional distillation. What does it do? It separates based on boiling points. 2. Cracking. What does it do? It breaks big molecules into smaller, more useful ones. 3. Reforming. What does it do? It rearranges molecules to improve the quality of fuel. Separates, breaks, rearranges. Seriously, go ahead and screenshot this slide right now. It's perfect for your last-minute revision. And before we wrap up, here are my ultimate exam tips for this topic. Number 1, master that mnemonic. It will save you so much time. Number 2, get a piece of paper and practice drawing and labeling the fractionating column. WAEC can and does ask for this. Number 3, if you get a cracking question, always balance your equation. 4, for your multiple choice questions, use the power of elimination. Get rid of the obviously wrong answers first. And finally, number 5, remember what makes our Nigerian crude oil special. It is light and sweet. You've come this far, you have absolutely got this. Excellent work today. You've really put in the effort and mastered the fundamentals of crude oil. But you know what I'm going to say? Don't stop here. The real key to getting that A1 is consistent practice. I really hope this session helped make crude oil a whole lot clearer for you. If you found this lesson helpful, please do me a huge favor, hit that like button, share it with your classmates and friends who are also preparing for WAEC, NECO, and JAMB. And of course, subscribe to our YouTube channel right now so you don't miss the next topic. And remember, for thousands of free practice questions and answers, visit www.examkp.com. Come on, let's smash these exams together.